Hello dear students. Today we will be discussing about spear gap for high voltage measurement. So the spear gaps are simply the arrangement of two metal spears. So you have one spear here, second spear here. So we are arranging these spears in a particular way that they are separated by an air gap between them. And what we do is that we will apply high voltages across this. So once high voltage is applied, once the applied voltage exceeds the breakdown voltage of air, so that is under normal conditions it is 20 kV peak per centimeter. So once it exceeds this voltage, there will be a flashover across this particular spear gap. So you can indicate or you can identify the voltage at which the flashover occurs, and that voltage can be measured. So by adjusting the gap distance as well as the diameter of the gap, we can use this particular arrangement for measuring different levels of voltages. It can also be used for measuring AC, DC peak voltages as well as impulse voltages. Now impulse voltage is something that is very similar to your lightning voltage or a voltage waveform of the lightning. So you'll have a waveform something like this. This is your time and this is the amplitude. So the impulse voltage will look like this. It will have a steep rise and then a slow fall. So such voltage is known as impulse voltage. So you can think of it like lightning. So such voltages also can be measured using this spear gap. The principle of spear gap is very simple. You apply the voltage across the spear gap. Once a breakdown occurs, the gap will be ionized, and the spark will be ionizing the air gap, which causes a reduction in resistance or will aid in conduction. So once this two starts conducting, the voltage drops drastically because before conduction it is open circuited. Now once it is conducting, it is short circuit, so the voltage will be dropping drastically, voltage across this spark. So at that moment we can measure. Just before that, the voltage is being recorded just before the breakdown, and that voltage gives the breakdown voltage for that particular diameter of the spear and that particular gap distance. Now if the field spark gap is uniform, that is, if you have a uniform spark gap, you will get a specified voltage within the tolerance limits. So here you can see that you are using a metal spear gap and you have a flashover between these spears. So the distance between the spears can be adjusted and the diameter also can be changed. You can use a different spear with a different distance between them, so that you will have to apply a different voltage to get the flashover or the spark. Then the spark is used to measure the value of voltage, the peak value of voltage, and the gap distance is also being recorded. Now this is 30 kV, not 22 kV. It is 30 kV peak for 1 centimeter. So it is 30 kV per centimeter. In the previous slide, I think I mentioned this is 22 kV. It is not 22 kV. It is 30 kV. 30 kV per centimeter peak value, and at this particular value you will have a flashover, and you have to consider standard conditions of 20 degrees Celsius and pressure of 760 torr. This is torr. So this is for a uniform field gap. So in order to get uniform field gap, we are using a spear, because spear will have a uniform distribution of field around it. So once a voltage is supplied, electric field will be produced, and this electric field will be causing the gap to ionize, and such ionization will cause a spark between them. So the voltage measurement is in terms of spear diameter as well as gap distance. In practical case, whenever the voltage is whenever the spark gap is breaking down, just before that the voltage is recorded, and you can see that on the voltmeter dial. Now this particular spear gap is designed for indoor operation. You must have identified that, or that there are two types of spear gaps. This one is a vertical arrangement, and here you have a horizontal arrangement. So you have two types of spear gaps available, and both are designed for indoor operation. So these are made of highly polished copper, these spears, and you can have you can have different standard diameters of the spears. So depending on the diameter, you have to apply different voltages. So the spacing is designed in such a way that you will have a flashover occurring near the sparking point. So this is your sparking point P. So your flashover will be occurring somewhere around that point. So it is designed in such a way that you will have a flashover from this P to this second spear. Now the spear is to be kept very smooth. If there is any irregularities in the spear, the field will not be uniform, and you will not get accurate results for the voltage measurement. So the surface of the spear should be free from dust, grease, or any other impurities, and it has to be clean as much as clean as possible. Now for different diameters and different spaces are provided. So for this particular design, if you are having a diameter of 250 millimeter or 25 centimeter, we can have a spark gap between them from 10 millimeter up to 20 centimeter. So you are able to adjust it like that. So you are given the option of adjusting the distance between them for a particular diameter of the spear. So once you change the diameter, you are able to adjust this distance between the gap from 20 millimeter up to 60 centimeter. So such adjustments can be made in the experiment setup. Now this is the actual arrangement. So you have an insulator setup here. So this is a insulator that supports the spear, and you have a spear shank. So this is the point where the insulator is being connected to the spear. Then you have operating gear and other motor for adjusting the gap distance at this point. You have high voltage connection coming from this point, and the sparking point P is at this point, and the diameter of the spear is provided, and the spacing between them, the height of this particular sparking point above the ground, radius. So this is a radius of clearance from external structures. So this particular structure has to be kept away from external structures at some particular distance. So that radius is given as B, and high voltage lead should not pass through its plane. So high voltage lead has to be away from this particular plane. Okay. So this is your vertical arrangement, and this is a horizontal arrangement. In both the cases, here you can see that your X is here. So your high voltage lead has to be away from this X. So your high voltage lead is provided at this point because you have a sparking point at P. So at P you will get a spark point. So you have to keep your high voltage terminals away from P, and so we are making sure that you are having a uniform distribution of field around this spear. So once you provide high voltage, you will have a field which is spreading uniformly in all the directions, and you can see that you will have a nearest structure which is close to the first spear is the second spear. So once you have uniform field around the spear, the nearest structure is this. So once the voltage increases, and the voltage exceeds the breakdown value of the air which is surrounding this, you will have a flashover between spear 1 and 2. Now this is a reference table which indicates the different values of voltages which is measured. Now A is for vertical arrangement and B is for horizontal arrangement, and here you can see that your gap distance is varied from 0.5 cm up to 100 cm, and you are using different spear diameters, 5, 10 up to 200 cm diameter spears are used, and here we are using here different voltages are being mentioned. For example, we will take for instance we take one example, that is for 4 centimeter spacing and for 10 centimeter diameter of the sphere. If you are having a vertical arrangement, you will get a flash over voltage of 106 kV. So this is in kilovolt. Once you apply 106 kilovolt, then only you are able to flash over between the two spheres. You must be remembering that the flash over voltage for air is 30 kV peak per centimeter. Okay. So here it is not 1 centimeter, it is 4 centimeters. So correspondingly, we will have to apply higher voltages to make the gap break or make the air gap conduct. Now there are many factors that influence the spark or voltage of sphere gaps. First one is nearby earth objects. So if you have nearby earth objects, it will reduce the flash or voltage, because already you have a conducting, you will get a conducting path nearby, so that the sphere gap will be breaking down, or the voltage will be reducing to lower value at a lower voltage. It will break down before even the sphere gap is or the flash or voltage is reaching near the flash or voltage of this particular air gap. If you have nearby earth objects. Now atmospheric conditions and the humidity will affect the sphere gap voltage. Your spark voltage will increase with humidity. So as the humidity increases, there are chances that your spark voltage will increase, and the increase is something like this. So this is your humidity, and this is spark voltage. And radiation supports the spark voltage. That is, we are eliminating the sphere gap with ultraviolet or X-rays. So that helps in the ionization of the air gap. So if you are doing that, the spark voltage will reduce. You are able to test that. You are able to identify lower voltage if you are making use of irradiation. And polarity and rise time of voltage waveforms also affects the spark or voltage. That is, if you are using a positive polarity, and if you are having two polarities, positive polarity waveform, peak waveform, and the negative polarity waveform, if you are making use of that, especially during impulse test, where your polarity is being defined, you can have an impulse like this, you can have an impulse like this. So these are two polarity impulse waveforms. So depending on the polarities also, the spark of voltage is seen to be different, as well as the rise time of voltage waveform. Rise time is simply the time required by the waveform to start from 0 and reach a particular value. So that is the rise time. So rise time is defined for each waveform, and for impulse also standard rise time is defined. So depending on that rise time also, rise time is how quickly your voltage is increasing from 0 to maximum value, or maximum value of 90% of maximum value. So in different ways you are identifying the rise time. So such polarity as well as rise time will be affecting the flash or voltage or spark or voltage of sphere gaps. So these are some of the factors that affect the spark or voltage, and hope you have got some idea regarding how sphere gaps can be used to measure high voltages. Thank you so much.